Welcome. So let's take a look at the switch. The first thing we do, I'm just going to explain the setup that we got running here. I'm going to show the IP interface on my VLAN. So you can see that I'm running a single IP helper, which is then forwarding in all of the DHCP requests to my DHCP server. If we switch over to my DHCP server, you can see I got a scope running here, and that's the scope that I will be able to boot from. So typically when you boot machines, you add in the options 66 and 67. So I'm going to go ahead here and type it in. Type in the IP address of the WDS Pixie service point that I'm going to boot from, and then I'm going to type in the network name here that we're actually going to boot from. So as you see, I'm going to provide the 64-bit version of the BIOS enabled bootloader. So this is what people typically have been doing over the years, is that they boot the BIOS machines using DHCP options. It's worked fine, nobody had any issues with it. And as you see, I fire up my machine here. If you see it quickly, you can see that I got the IP address, and I'm booting off my referral machine if I want to. I can press F12 here, and the Hyper-V virtual machine will slowly come to a download phase where it starts pulling down the image. It runs a bit slow. You could think it's actually not working, but it's just Hyper-V being very, very slow. Here you can see it's starting to do the download. So that's no problem. So I'm going to go ahead and switch. So I'm going to turn this machine off. As you can see, it's starting to do the download. And then what we do is we go in and we change this behavior to then boot off the EFI loader. So the name of that is WDS mgfw.efi, and of course if I try to boot my BIOS machine again, that will then prompt and say, hey, I think it comes up with an error saying that the bootloader is too big or something. Doesn't make any sense, but it's basically, this is not an EFI machine, it doesn't understand the format. So it just goes on into the boot sequence and fails. But of course, if I boot up my EFI machines, one would suspect that this is going to work. But that's the case is that WDS sends out the file fine, but then as it comes into the bootloader, it completely grinds to a halt. And if I had a different EFI bootloader, that would load fine. It's just the Windows Deployment Services EFI loader that grinds to a halt. And as we were doing research around the 2-point software for our iPixie Anywhere product, we found that if you actually set the option 60 for an EFI machine when you load using DHCP options, that basically loads fine. So I'm going to go ahead here, add Pixie option number 60, put in Pixie client, and now I've got 3 DHCP options. I've got my Pixie client, my boot server, and my file name. So I'm going to reboot this machine. You can still see it's still stuck there. And what was earlier a very slow process, you can see it's already now booted fine. And here you can see it's a tremendous difference in the speed. So after a bit of network sniffing, we saw that the machine was actually going against the DHCP server instead of the Pixie server. So when we enabled option 60, it goes to the right server, which got us thinking that, hey, this must be a bug in the EFI loader. So I'm going to try to file that in Microsoft to see where it goes. But what we're going to cover now is to use policies on how to enable us to boot BIOS machines as well as EFI machines at the same time. So if I try to create a new policy here, you can see that I only got the default vendor classes. There's nothing that I can control my DHCP and Pixie options in. So we're going to go ahead and define some new vendor classes. This is in the documentation that's on the 2-point website as well. So by default, when a Pixie machine comes out and tries to boot, it sends out in the DHCP request, it sends out what kind of hardware that it actually is. So this vendor class that we're putting in then basically figures this out, looks in the file, or looks in the package that it gets, and it gives out the right file. So here in the ASCII of the vendor class, I type in to say if there's something comes in looking like Pixie client :arch :0007, it's an x64 machine. If I do the same thing for the x86, the vendor class is slightly different, so instead of being 0007, it's 0006. So these different options are then available in the document as well. So this is just a short little guide to show you how to do it. So I type in my ASCII code, and if I also want to, of course, now I can boot 64-bit UEFI machines and x86. Of course, I want to be able to boot my BIOS machines at the same time, so I add that in. And the Pixie client code for a BIOS machine is a 0, so it's actually 5 zeros in a row. The 4 default zeros and then the 0 in the end. That basically defines my bootloader. It's important that you type this right. It is case sensitive, and so any sort of little mistake in here makes the difference. And now I have my 3 vendor classes added, close, and then I can go and create a new policy. So first I'm going to create a new policy for my 64-bit machines. So all of my x64 UEFI capable machines will be trapped by this policy rule, and this rule will then give out the correct options. So give it a good description, and basically it sets the right policy. You can type in whatever you want in these policy names and descriptions, but it's good to have something fairly straightforward. And then of course you want to select the 64-bit vendor class that I created earlier. Make sure that you click the append wildcard, and make sure you click the add button after that, so you can see the little star there on the rule. We don't want to limit to a certain subset, and then we get the options to fill in if we have a match on this policy rule. So I'm going to go down, and of course I'm going to click the 60 option, and I'm going to set the 66, and I'm going to set the 67. So make sure that that is Pixie client, and then we go down to 66, type in the IP address. Could use FQDN if we wanted as well. I find that IP works better in most scenarios. In case there's some issue with the name resolution, we know that the IP will always work. And then we type in the boot name. It's SMS boot for the SMS or the configuration manager Pixie source point files, x64 WDS mgfw.efi. Hit OK, see summary, and click finish. So that basically creates a response for our machine. So if I go back to my scope options, I can then do an F5, update, and I can see all my new ones. So if I go ahead and basically remove my default ones, so my 60 client, I can delete that, and I delete the 66 and 67, the response will come from my policy rule instead of my actual default. So they're all gone now. So technically, if I hadn't had my rule, nothing would be able to Pixie boot. So let's go back to my Pixie UEFI machine, fire that up. You should see that it straight away goes into the same kind of behavior as we saw earlier, but the difference is that this time the rules came from my policy instead of the default rules. Of course, if you want to make a simple setup, you can use the default bootloader coming down to be the BIOS one, and then you only filter a rule for your UEFI one, and you'll be kind of done now. But in this case, I want to show that it's actually the rules that trap these. So you can see my BIOS machine. This is again any response with 66 or 67, so that will just sit there forever, and then eventually say no boot file name received. So I'm going to turn it off, go back, and then add in another policy, which basically enables me to do my BIOS machines. So Put in the BIOS. An interesting thing is that it's the same bootloaders both for x86 and x64 machines. So you don't need to be worried about that. The only problem is that, of course, if you deployed an x64 image with the task sequence, then you need to make sure that you have a 32-bit one available for you to boot, so otherwise you won't be able to boot. So in this one, on my BIOS one, of course, then I don't set the option 60. I only set the 66 and 67. So just make sure that that's not checked. So type in the IP address and then type in the firmware name. After that, the boot file is of course then the SMS boot /x64 WDS NBP, and NBP stands for Network Boot Program, which is the definition of a bootloader that you get through Pixie. So now if we go back to our scope options, doing F5, we can see that we got two different rules. The UEFI responds with 3 options, and the Pixie for the BIOS responds with 2. So let's go up and try again to fire up our BIOS machine, which this time will of course then respond. So then again, press F12 here, you can see that it will probably be a bit slow. So there's been a lot of posts and articles on forums saying that DHCP booting doesn't work with UEFI or with WDS and Pixie Search Point. As long as you know what you're doing, it works really, really well. I think there is a bug in the file loader that reads the option 60 completely wrong. So instead of not being there, it has to be there, and that's why people have said that, yay, it doesn't actually work. I go back to my Pixie UEFI machine, you can see that the task sequence runs fine. There's no difference from if it was booted using the other one. That kind of sums it up. Thank you.